Hello, this is solving systems of equations, special types, example 2, and I'll be solving this system of equations and looking at the two equations. It looks like it's set up so that substitution would work pretty easily because this says y equals. If you have y equals or x equals, you can substitute equals for equals, and I'm going to substitute what I've just put in the dotted circle for y. So I'll set up the first equation for substitution, and I just leave a big set of empty parentheses for the y because I'll be substituting this in. And now continuing trying to solve this equation, I'll distribute this 2. That's actually a negative 2. 2 times 1/2 is 1, so this becomes 1x. And negative 2 times positive 2 is negative 4 equals negative 4. And this time, pretty unusual, x minus x, that's 0. So I end up with negative 4 equals negative 4, and that's true. And similar to this example we did way back when we were working regular equations with variables on both sides, we ended up with an identity, something that's true. 2x plus 10 equals 2x plus 10. That's certainly true. If you continued this, you'd end up with 0 equals 0. And when that happens, when you get an identity like this, all real numbers will work. And that's the case here. We have an identity, negative 4 equals negative 4. So in this circumstance, all real numbers will work. And if you're wondering what's going on here, these two equations are really the same equation. So if you graph this line and you graph this line, you'll see that they are right on top of each other. They are exactly the same line. To illustrate that, I'm going to multiply this second equation times 2. That gives me 2y equals 1/2 times 2 is 1. So, and 2 times 2 is 4. Now I'm just going to manipulate it a little bit to try to make this equation look like this equation. I'll subtract x from both sides, and I get minus x plus 2y equals 4. And now if I multiply this equation by negative 1, I end up with x minus 2y equals negative 4. So starting with this equation with some algebraic manipulation, I ended up with the same equation. So that's why any number will work, because these two equations are really the same line.